Hello, my name is Jeffrey Wang, and today I'll be discussing pathfinding and risk aversion from analyzing aerial images. Over the past decade, drones have taken an increasingly important role in our lives. However, when it comes to complex maneuvers, autonomous robots tend to either perform remarkably well or fail catastrophically, making risk evaluation an important aspect of robotics. Here, we are interested in taking an image from a UAV, computing an optimal path for an unmanned ground vehicle to get from point A to point B, and then evaluating the risk of that given path. Our approach is to train multi-class classifiers for roads, which are easy to traverse, and buildings, which are difficult to get around. For features, we use RGB coordinates in conjunction with the filter bank of Gabor filters or steerable Gaussian derivatives. In the interest of computational speed, we train a separate linear SVM for each training image we provide. Then for each test image, each SVM will vote on whether a pixel is a road, building, or neither. Then, we take these percentages and compute a weighted average of a danger factor associated with each pixel type. We can then use Dijkstra's algorithm to compute an optimal path. In these images, the blue path is the optimal path, whereas the red path is the result of our analysis. As can be seen, our algorithm performs well under circumstances where the road and building boundaries are clear, as shown here. However, when there's a single building or a driveway that bridges two adjacent segments of road, the algorithm typically tries to cut through there, which happened in 3 out of our 10 images. We find that RGB and steerable Gaussian filters perform similarly, although this might be an issue with the large scale of our Gaussian filters, since each pixel was normalized to 1 square meter. Gabor filters perform better in terms of cross-validation accuracy, but the pathings are still being computed at the time of recording. We also try to use a universal text-on dictionary from the Berkeley segmentation database, but performed poorly and took too long to train. In conclusion, the proposed method, while a potentially useful metric, still needs work on robustness on distinguishing roads from buildings. Potential ways to fix this would be to train a text-on dictionary with optimized filters, or to take advantage of the fact that pixels that are next to each other are more likely to be the same object. Also, correcting for lighting changes in scale selection is essential before this method can see common use. Thank you.